Okay, good morning, everyone. As people are still joining, we will wait for another 1, 2 minutes and then we can start. Thank you. Okay, I guess we can start, and if there are, because there are many people registered, and I think they will join in the next couple of minutes, but they won't miss that much because will start actually with the presentations from the Indian national committees that are actually organizing this webinar. So, good morning, good afternoon, or good evening, depending on where you are connecting from, for our collaborative webinar organized jointly by CIGRE Engineer Romania and Engineer Serbia, called Ancillary Services, a TSO versus Aggregator Perspective. We came up with this specific topic given actually the needs of the current power systems. Here, taking into considerations all the changes that are happening in Europe and worldwide, with a lot of renewables connecting to the power grids, and so on. So this imbalance is the topic. It's an important one that are being discussed worldwide by the technical specialists. So the ancillary services are one of the key aspects that should be addressed in this area. So for this specific topic and webinar, that will also be posted on YouTube. It will be also recorded, and people can also check it later. We'll have as two main speakers coming from both Romania and Serbia. From the Serbian side, we have Nikola Tosic, Market Division Manager at the Serbian TSO AMS, and Olivian Savin, Country Manager Nano Energies Romania, one of the main companies in Romania addressing ancillary services and acting as an aggregator. Uh, in terms of the agenda, this webinar will take about 1 hour and a half. We will also have a Q&A session at the end of this webinar, so make sure that you prepare your questions for the ending of this webinar for our speakers. And if you want to check the bios of our speakers, they are already posted everywhere on social media, and we will also let them shortly introduce themselves when the moment will come. This being said, I will start accordingly with the agenda, with the presentation of Engineer Romania. Very briefly. So we as NGN National Committee we're a group of about 90 young energy professionals, very well distributed both in terms of gender and age, that are coming from some of the main companies in the energy sector in Romania, and also from the universities. And talking about about the activities that we organize, and we align with the international level with other NGNs. We are, as you see here, one of the main, let's say, initiative is this kind of joint webinars, as is the case of today's event. We also organize a lot of physical events from the young professionals in Romania, such as dedicated workshops on different topics, where senior specialists are coming and explaining to our young energy professionals, and also to other specialists in the energy sector, the hot topics in the energy sector that are happening. We are also organizing interviews with successful young energy engineers in order to inspire others to make research, to work in the industry, and promote CIGRE's activity. And also, other than that, we organize technical visits, and we started also an electronic magazine called Volta, that is also in English version. So for the coming editions, if you're interested in writing, just let us know about a specific topic. And obviously, dedicated conferences. We were founded in 2015, and as I was telling you, we are representing a lot of companies in Romania. Um, I would like to bring into your attention two main initiatives before finishing my presentation. The first one is our upcoming Regional Southeast European Conference, that will be organized in 2026 next to the Black Sea in Constanța, Romania, at the Maritime University. This is the Next Generation Network Conference, where we invite all NGNs worldwide to join us. And if you are a young energy professional, and you want to present your work, participate in discussions with other young energy professionals, and address topics related with power systems, this is the great event that focus not just in this area of Europe in Southeast, but we will also address different other topics. And it's also a special event because we will also celebrate 100 years since CIGRE Romania was founded. And also another initiative that we just started together with NGN International Executive Committee is called Present Me Your National Power System. So every month we will present the particularities of a national power system. We will start this month with Italy, next month with Colombia, and each month in next year we will present a power system worldwide, because, as you may know, they have different particularities that are differentiating them. So it's important to exchange knowledge in this area. So if you are coming from a country that want to present your national power system, let us know. Okay, I will stop sharing my screen, and I will hand over the floor to Yana to present to Yana and Elena to present the Serbian National Committee and the activity of also IEEE Power Energy Society activity in Serbia and Montenegro.
Okay, I hope that you can see my screen.
Yes, we can.
Okay, hello everyone. My name is Jana Toholj, and I'm representative of NGN Serbia. At the very beginning, I would like to thank Olivian and Nicola for accepting the invitation, and our speakers, and especially Bogdan and Jelena for the great support in organizing this webinar. NGN Serbia is an organization founded by Nebojša Petrović, President of CIGRE Serbia, and Maja Adamović, President of Women in Energy Serbia. We started our organization this year in January, and at the moment NGN Serbia has 40 members. Our main goals are sharing knowledge, networking, organizing NGN events, and CIGRE events. In this short period, we had several activities. For example, we participated at CIGRE Serbia conference held in May this year. Then we start organization for NGN Showcase competition for Paris Session 2026. Then we, in cooperation with China Southern Power Grid and CIGRE, one of our members is doing internship in China now. Then we start collaboration with IEEE PS Serbia and Montenegro, and now we have this webinar with NG in Romania. For more information about NGN Serbia, you can find us at social media. This is our first webinar, so thank you everyone for joining us today. And now I would like to give the floor to Jelena Ponoćko, representative of IEEE PES Serbia and Montenegro. She will talk about our collaboration and IEEE PES organization. So Jelena, go ahead.
Thank you very much, Jana, for this great introduction. And it is an honor to be a guest participant in this webinar, especially because it is the first webinar. I was not aware of that for Serbia NGN committee. I will not take too much of your time. So let me just share my screen for a sec there. And I'll turn the slideshow. Can you see my screen now?
Yes.
Yes.
Okay, that's great. So just a brief introduction. So I'm Jelena Ponoćko. I'm a senior member of IEEE PES. I've been a volunteer for IEEE for the past 10 years now. I'm currently chairing the Serbia and Montenegro chapter. The chapters in IEEE are basically equivalents to national committees in CIGRE. And in addition to that, I'm also chairing the IEEE PES Expanding Collaboration and Engagement Committee, which used to be called the Diversity, Equity and Inclusion Committee. My idea today is basically to convey two messages. The first message is that we need more volunteers in IEEE PES, just as we do in CIGRE. We need more people to get involved, whether they are students, professionals, retired members. There are too many challenges that we are facing in power and energy today, and we will keep facing new ones in the future. So we need to have a stronger involvement, and institutions such as CIGRE and IEEE PES are definitely excellent way, and they really serve as a platform to bring people and expertise together. A few words about IEEE. So IEEE has been, so I think I'll have to move this so that you can see my screen fully. IEEE was founded in 1884, just as CIGRE, a very influential institution that has a vast global reach with more than 400,000 members. IEEE is probably best known for its publications, so standards, research papers. It organizes many conferences around the globe on a yearly basis. Apart from its technical impact, it also has a very important social impact. So it is well known for its global humanitarian efforts, for its education initiatives, and so on. Now, the IEEE PES as a society is only one of the 39 societies in IEEE. So all the societies are more or less organized in the same way as you can see here. PES is the second largest society after the Computer Science Society, and it's one of the oldest ones. The way that IEEE is organized, and its societies as well, is it is split into regions. So Serbia, as well as Romania, belong to the geographically largest region, which is region 8, comprising of Europe, Middle East, and Africa. And the way that PES works is thanks to its chapters. So all the volunteering work is basically done through chapters. Romania has its chapter, Serbia and Montenegro, as two countries have one chapter, and there are professional chapters, so people who are working, and there are student chapters comprised of students either undergraduate or postgraduate. So if you are a student, I do recommend that you investigate who the PES contacts are in your region and to get involved. Of course, as a professional as well, it is never late to join. Something that I would like to highlight is the need for the joint effort. So something I mentioned at the very start. And in line with that, CIGRE and IEEE PES have had the memorandum of understanding for years now, but the newest one has been updated and it will run until 2030. And as you can see, there is a mutual desire to organize joint technical activities. So there will be a global event organized either by CIGRE or IEEE PES every other year. Also, there will be joint technical deliverables, joint working groups. So any challenge or any topic that are of common interest for both organizations will be considered for joint work. All the activities are overseen by the president of IEEE PES and also by the president of CIGRE. So this is not happening only on paper, it is happening in reality, and we at the local level can do our best to encourage activities like this. So hopefully from next year we'll have more CIGRE IEEE PES activities at Serbia, Montenegro, Romania level as well. And just to finish some announcements for next year. So the IEEE PES Serbia and Montenegro chapter next year will be hosting a talk by Professor Federico Milano from the University College Dublin in Ireland. He will be visiting Croatia, Bosnia and Herzegovina, and Serbia. His main topic is power system dynamics, so we'll share more about that. And also in May 26, there will be a conference, Nikola Tesla Days, organized by the Electrical Engineering Institute, Nikola Tesla, and there will be a special session organized by IEEE PES. In terms of our future activities, we are planning technical panels such as this one, so workshops, webinars, student events, mentoring programs, and so on. So if you want to learn more, there is a link here on LinkedIn, and of course be free to get in touch with myself as well, and I'm happy then to help organize something together. Thank you very much, and I will let our main speakers now take the microphone.
Thank you, Yelena. Thank you, Yana. Yeah, I think it's crucial for this collaboration between CIGRE and IEEE, as is the case between industry and the academia. And I'm glad that we can also see results on this way. Okay, sticking to the agenda, we will start with the highlight of our event, the perspectives given by our speakers today, and we will start with Nikola Tosic, Market Division Manager at EMS in Serbia for the TSO perspective. Nicola, the floor is yours. You are ready to start your presentation. We can see your screen, and everything is fine. Thank you.
Great. Good morning, everybody. Welcome to today's presentation. I'm Nikola Tosic, Market Division Manager. I'm working in EMS, Serbian TSO, for about 15 years. And now I will speak about some new or some old topics, but maybe they are very interesting for our participants today. So ancillary services, everybody is speaking about ancillary services. We will see what that means for the TSO. First, I would like to share one slide which is independent from ancillary services, but just to give a clarification of what are they used for, and I will put my light on one part of ancillary services. Of course, we do not have time to explain everything, but for the balancing services, maybe it is the most convenient for today's presentation to say what are the balancing services, and on frequency ancillary services. I will maybe have a little less time for speak about it. So let me show you what are the logic of the electricity market. Maybe it's interesting for the participants to see. And first thing, when we speak about electricity market, is that electricity supply. What is electricity supply, and when the ancillary services came in. So supply of electricity, of course, everybody knows everybody needs to consume some energy. So we have here one consumer, which is covered with one supplying contract. On the left, you can see the type of that contract. It is full supply contract. It means that everything which I consume, it is covered by one contract and one participant called supplier who needs to resolve its question about balancing responsibility. Balance responsibility means because that I'm a consumer, you see that I cannot consume the exact amount of electricity which is nominated to the supplier to obtain on the market. My consumption, I don't know whether you see my mouse or I can take a pointer. So my consumption is something like this, and the supplier or who obtained the electricity on the market, on power exchange or from some producer, he is delivering me this. The TSO is responsible to cover this excess or this surplus of energy. The other type of supply, it's very similar. When I buy the energy from one supplier or second, third supplier, fourth supplier, but I do not have a full supply contract. So there is no party who is covering me for this. So I'm transferring the balancing responsibility to some party who will be delegated to pay to the TSO who is using its efforts to cover this surplus or this leakage of energy. Let me show you how the electricity markets works in one big time frame from couple of years in advance until the right this moment, and where the ancillary services came in. So everybody know that for good work of electricity of the power system, we need good planning. So everybody is planning its actions a lot of years in advance. We are starting maybe from 10 years in advance, going through the 1 year in advance, or after that 1 month, or maybe 1 day before the real time, and we can see what's happening in the day D or in the moment we consume our energy. So first there are of course participants who plan how do they invest their how do they work on the market, whether they find some consumer, whether they need to have some contract with the producer, I don't know, and they're trying to get their own place on the market. So we are starting with the long-term market. It is let's say 1 year in advance or year -2 in advance. So they're trying to sign the contracts, especially speaking about suppliers. They are trying to make a contract for selling of energy and buying of energy. Of course, supplier wants to buy cheap and sell the energy with a higher price. So they're trying to organize. They're trying to get some contract for the supply in current moment. So maybe one company from Serbia wants to have the consumption in Romania because maybe in Romania there are higher prices, maybe in Serbia there are lower prices, and they want somehow to export the energy from Serbia, from the place where the energy is cheaper to the place where the energy has a higher value. So they're just planning. When they want to export the energy from Serbia to Romania, currently they need to get the capacity on the tie lines. So they are planning, okay, my consumption is having, I don't know, 10 megawatts per every hour, per every day, per every month in the year. So I will go to the yearly capacity allocation. So to buy the capacity for transfer of the energy from Serbia to Romania and participate on yearly capacity allocation. And they say, okay, my energy which I sell to the consumer in Romania is maybe 70 euros. My production price in Serbia is maybe 60 euros. I have 10 euros to spend on the capacity in order to be on zero or a little bit less if I want to be in some to get some income. So they're participating on yearly auctions. If the price on yearly auctions is, I don't know, delivering like 5 euros, maybe the price on capacity allocation is a little bit higher than 5 years. Now he didn't get. Now he's going to monthly auctions, delivering maybe 6 euros, 7 euros, and after that going to yearly capacity allocation if there is a need. At the end, he is going to the intraday and get the capacity for free, but he is not sure whether the capacity is available there. What is the question? The consumption is not always 10 megawatts according to our contract. Maybe it is like 10.1, 9.5, 10.5, 11 megawatts. Maybe that factory, that client is going to some, I don't know, reduction of consumption, something, or there is a certain outage of the power plant. Now the ancillary services came in. So he bought the energy for 10 megawatts, get the capacity, export it to Romania, and he wanted to consume 10 megawatts, but suddenly there is a outage of the power plant, or the outage of the factory, or outage of the consumption, and he is now having the surplus of energy. Now the TSOs came in and say, okay, I'm operating the balancing market, who can take that surplus of energy? In other case, if there is some, I don't know, disconnection of the tie line because there is some reconstruction or something, he couldn't get the all amount of the capacity for the certain day, some, I don't know, in July, maybe then we have a tie line disconnection. He can go to the spot market in Romania and say, okay, I'm having the contract for 10 megawatts. My goal is to have like around 70 euros selling price. I will go to the spot market and get some energy. Maybe I will pay, I don't know, 71 euros, 73. I'm ready to pay that. Or maybe if the price is higher, I cannot buy on the market. Also, if I cannot buy the full amount of energy I need, ancillary services market came in and say, okay, TSO is saying in first time we will have a surplus of energy. Now we have the lack of energy, and we say, okay, the TSO will deal with that. Now we have around, I don't know, a couple of megawatts less than we need, so we will activate the balancing market. We can find on the balancing market the participant who will produce more in order to keep the balance of the system. After the real time, there is that calculation of imbalance and calculation of amount of energy which we procured on the market in order to cover those imbalances. This is the one comprehensive picture which shows which participants are active on the market. So I don't know where we can start, but I will briefly inform you about this picture. It is very hard to explain, and we do not have so much time, but I will say that we have here wholesale suppliers who do not have the consumers. They are just buying and selling of the energy. Retail suppliers means that they can buy in the market and also have some consumer. We have TSO, we have cross-border flows. We are having our network depicted in blue, where the generators are connected, some renewable sources are connected. We have our consumers. Consumers can be like small consumers like households, and bigger consumers like factories who are active on the market, consumers, which are households or some small companies, small agencies, entrepreneurs. They're mainly on guaranteed supply. That means that the state organized in some way and said you will have the price of electricity which is subsidized, like it would be a better price than when you are on the market. Of course, now we will have storages on the system, of course, distribution system operators of closed distribution system, and we have one participant who is depicted in red. It is power exchange, or as we are following the EU legislation, we call it NEMO. NEMO means that it is a power exchange who is eligible for market coupling. On the right side, we have the Serbian state. We have one state-owned company which is dominant participant, and has its own regulations on which it is working, and it is guaranteed supplier for Serbia. But in EU countries, generally that level of state-owned company is reduced, and Europe is trying to have everything set on the market without that dominant participant. But we have dominant participant and trying to make the market where we have the influence of it. Now we have a big amount of definitions from EU legislation, Directive 944 2019 and EU 943 2019. I will not go through this, but when somebody wants to download this presentation, he can easily look on it. I will just read one most important definition for today's presentation. It is ancillary service. But as I briefly introduced you a little bit before, but we will just repeat it one more time. So ancillary service, that is a service necessary for the operation of transmission or distribution system, including balancing and non-frequency ancillary services, and not including congestion management. So as I said, and I was putting the light on the balancing services, that means that TSO is using ancillary services in order to maintain frequency. So in order to balance the system, we all know that the system must work in a postulate on a basis that production and consumption are the same. As we are interconnected, that means that in whole interconnection, the production and consumption need to be in balance. That means that if in some country there is, I don't know, more consumption than production, that will logically mean that in some other country there is more production, and there are some cross-border transactions in order for everybody to be in balance. For those non-frequency ancillary services, the market is still developing for them, but they are connected mainly for the keeping the local congestions, or where the situation came when when there is a congestion of the tie lines or some substations. So the TSO is using non-frequency services, ancillary services, in order to solve the problem in one specific spot. And balancing services are used for the entire system. We will see on the next picture how the ancillary services are divided. So on the left we have balancing service and balancing service market, containing frequency containment reserve and energy. Second is automatic frequency restoration reserve and energy, and manual frequency restoration reserve and energy. In the past we call them primary, secondary, and tertiary reserve, together with energy. I say with energy because European legislation says that ancillary service, or not ancillary but balancing service, means reserve or energy or both. For non-frequency ancillary services, so as I said, to solve the problems in specific spot of the network, we have the services for voltage control, and additionally for black start capability, instant operation capability. So when the TSO needs to deal with some problem which is not balancing, he is using those non-frequency ancillary services. I will mention later who are participants on those markets. And we have one participant also on presentation here today. For the balancing market, as I said, you can remember the picture from the time frame. It is only one part of overall wholesale electricity market. TSO buys and sells the energy in order to maintain the balance of the power system and ensure the secure operation of the system, or if there is activation of balancing energy, it is activated from some resources who are kept in the reserve. So if we use all of the reserves, we are activating this market in order to restore the desired level of reserve for our system. When we say balancing market, we say also balancing market, balancing mechanism. Those are, let's say, synonyms, and balancing market or balancing mechanism is a set of procedures used to manage the balancing market. Everything about balancing mechanism and balancing market should be elaborated in balancing rules. Of course, every EU and energy community TSO is organizing the market in that way that it has its own rules where the all characteristics of balancing market are described. So one just insight in the balancing rules that it is explaining how the participants are submitting the bids for the energy. We remember the consumption and supplier. So there are some bids for the activation of balancing market participants. After that, we need to settle the activated balancing energy. So who is paying to whom, and who is receiving the money from the TSO, or who the TSO is paying. As we do not have so much time, I will give you a short example of how the market participant who is delivering the balancing energy, how he is thinking. So he, of course, if there is a lack of energy in the system, TSO needs to activate the upward regulation. If there is a surplus of energy, TSO needs to activate the downward regulation. So one market participant, for example, some hydropower plant, I don't know, or some storage, or I don't know, some participant gas power plant, when that power plants do not sell all energy on the market, or there is a need to stay in the reserve according to some other procedure which TSO is conducting, and his TSO is paying for the reserve. So if there is a need for activation of the energy, or in order that energy produces more, he's delivering the offer to the TSO, something like this. So from first 50 megawatts, he wants that to be paid by 55 euros per megawatt hour. I don't know, for other 50 megawatts, he wants to be paid with 62 euros per megawatt hour, and etc., until the amount the TSO needs, or until the amount where the TSO is accessing all the capabilities of that power plant, of that participant, and after that it is going to other market participants who has more reserve, which are a little bit higher costs. In the other case, when the TSO has the surplus of energy, he's activating downward regulation. That means, okay, you are producing the energy, you are selling the energy on the market, but you have reserve for downward. Please shut down your power plant, and you will pay me a little bit because I saved your fuel for next hour, maybe. And in that way, the participant is paying to the TSO. And this mentioned here is the case when we have the positive prices. In Europe, there is a trend for negative prices. So where the negative prices appear, the participant thinks a little bit different and say, okay, I do not want for you to pay me for upward. Maybe I have cycles where I need to shut down my power plant because I didn't sell the energy on the market, and now I'm paying for keeping me activated because my costs will be a little bit higher than the price I will give you. Generally, when I speak for the positive price, as I said, the TSO pays to balancing market participant if we activate them for the upward, when we activate them for downward, the participant is paying to TSO. In Europe, so that is the thing for the balancing market, but the TSO needs to be neutral in this market, so he's keeping the balance. So when somebody is making the imbalance, somebody is correcting that imbalance, and TSO is paying to the participant who corrected, and taking the money from participants who made the imbalance, and vice versa. If the participant is positive, he gets the money, and the participant who participated and reduced the production is paying a little bit, and that money is transferred through the TSO in those two participants. Participants in balancing mechanism we call them balancing service providers. As Serbia is now implementing the EU legislation, we are using more and more this syntagm balancing service provider. I'm still using participant in balancing mechanism, but generally we need to speak about BSPs, balancing service providers, and on the market there are participants who can deliver the energy and possibly the reserve, and those are producers, even renewable energy sources, because they can reduce their production. Of course, to increase the production is a little bit tricky, but for the downward, they are surely very valid participants. Also, we have storages and also aggregators. I explained this picture a little bit before. So on the left side is a balancing mechanism or balancing market, and on the right side is balance responsibility. So when we follow the arrows, we can see when the balancing service provider delivers the energy, he gets the money. So what happened in the system? BRP is negative, balance group is negative, or it's better to say that overall system is negative. So the participants who are negative are paying to the TSO, and he is getting the money and transferring to the balancing service provider. For the energy, balancing service provider is providing the energy to the TSO, and TSO gives the energy to the participants who are in negative imbalance. If there is a situation when some BRP is negative or some BRP is positive, the system will say, okay, we will observe the overall situation in the system, and we will activate only the amount of energy we need. In the other direction, if the overall system is positive, they are leaving the energy in the system, and we are activating balancing service provider for downward regulation, and they're paying a little bit, and we are transferring that money to the participants who are positive on the market. What is important to say is that when we activate balancing service providers, we are calculating the price according to that price, balance responsible party is paying or getting the money, and generally that price is average price of activated energy. And so if we activate the AFRR or secondary balancing energy, and MFRR or tertiary, we are combining those prices and multiplying the energies with pricing and dividing it with the whole amount of the energy, and we get some average price for which the participants are paying. When we see this picture is, let's say, future or present day. So when I say the balancing service provider, I'm just explaining how it's working in one country for the future, or maybe for the future for energy community parties, or this part of non-EU countries, or maybe for EU countries it is a reality and present. And that is the thing when we get to the balancing platform. That means that why should I activate my participant if in one direction? If, for example, in Romania there is a participant who can be activated in other direction, maybe we can agree on some kind of cooperation in order to avoid unnecessary spending of the reserve and just transfer the imbalances, or get some function in order to activate less energy. So some smart people from from Europe wanted to deal with it and made the balancing platform. That those balancing platforms are the place where the TSOs are exchanging its offers for the activation and activate the reserves on optimal way. We are going to the end of our today's presentation on 25 minutes. I will just show you what are the directions of development of the electricity market. We see how the market looked a couple of years ago. Now it is going to be something like this: integration of national markets into the European market. That is a one way where we go, so it is through to the Europe, and the second way where we are going, it is the integration of renewable energy sources and distribution resources on the electricity market. That means that we are trying to cope with new participants, new technologies, dispersed energy sources on the grid, and maybe use their services in order to even for ancillary services. That would be all from my side. If we have any question, I'm here to listen. I can ask you to follow the EMS website, where we have some information about prices, about market rules, and also to follow on LinkedIn one think tank organization who will deal with the aggregators in the future. That is also very interesting. It would be to listen to the and look for the results of this study. And my contact information is stated here. If somebody wants to contact me, I'm here or available online to answer to any question.
Excellent. Thank you very much, Nicola, for all the insights provided and the way you presented everything very clear and exactly the information our audience needed from a TSO. I will ask the people in the meeting to keep their questions for the Q&A sessions that will follow after the next presentation. And for this, I will invite from the Romanian side Olivian Savin, country manager Nano Energies, to give us the perspective of an aggregator and their activity in Romania. Olivian, the floor is yours to start the presentation.
Thank you. Hello, everyone, and very interesting presentation and discussion that we have right now. I hope you see my screen.
Yes, we can.
Okay, great. So yeah, thanks again, Bogdan, Yana, Elena, for the introduction and for this discussion that it needs to happen also between the TSOs and participants in the market. So in this regard, thank you also, Nicola, for presenting the TSO perspective, which is very interesting how the TSO it's seeing this. Let me jump to the presentation. It's working.
We no longer see the screen, Olivian.
Sorry?
We no longer see the screen.
Okay. Let me then.
Yeah,
let me switch.
we saw it for like a minute and then.
Okay, let me do like this. And now?
It's loading. Just a moment. Yeah, okay.
Okay, so I'm entering in presentation mode. Okay, so hello everyone. My name is Olivian Savin, so I'm the country manager of Nano Energies. Few things about me. I started working on this topic more than 8 years ago in France, where I done my PhD. And I created a tool to estimate the startness of a hydropower plant because the balancing services, the BSP, as mentioned before, was needed in the market. Now I'm coordinating the company in Romania, which is one of the first independent aggregator in the country. A short brief of the agenda and the presentation that I will do today. It's split in two. First of all, we will speak about ancillary services and what's the philosophy behind them. And the second part of the presentation, we will see exactly a case study of batteries, BESS, as we know it in the market, which is a hot topic right now and very important to the system nowadays, because it's storing energy, but also it's because it's becoming a trend. Like everybody wants to have a battery, and we will see behind how a battery it's operating. Just a few words about the company. Nano Energies, it's part of a bigger company which is called CIGRE Foundation, and we are we are in more than 30 countries with 6 offices worldwide, and we have more than 400 megawatts in flexibility as BSP. We also operate in Europe, but we have offices in Japan where we own batteries over there, in Germany, in Belgium, Czech Republic, Croatia, and now in Romania. Also, we have offices in the United States where we are trying to develop and to implement batteries over there. So let's get to the topic. So ancillary services, we will see how does it work, how flexibility works, in fact, and what an aggregator is doing, and what's the infrastructure of an aggregator. So we have this current situation. We see increased participation of renewable resources, which are intermittent energy. We see the fluctuation in supply and demand, and we see the limitation of the grid. So what's the next step? It's like, of course, we need greater flexibility in assets. So what an aggregator is doing, it's coordinating these resources. It participates to the balancing market, the one that was presented before, and of course integrates digital solution. Who can participate in this market? market on short producers and consumers. What's they're in for them? It's like they're generating, they're contributing to the system security. They are generating additional revenues for reservation and activation as two parts of the market. And of course, there is a cost optimization for them. What is happening exactly in the market for the system. So when there's too much energy consumption, the frequency will decrease. So we need to produce more. That means that there's a positive balancing energy. When there's too much power generation, means like the frequency will increase. So there's need to consume more and to arrive at the system where it's balanced at 50 hertz, and where the consumer's energy meets the producer's energy, which is called a system that it's balanced. So how flexibility works? So we have two main parts. We will focus on the one that we see here on the left side, which is called support services. We have FCR and then the AFRR and MFRR services. These services are meant to help to keep the balance the network, and they're in different times activation, let's say like this. So for the FCR, you have it in 30 seconds. For the AFRR, you have it in 5 minutes. And for MFRR, it's 12.5 minutes. Here we have a graphic in seconds. And of course, there is also the business flexibility that it's something aside of the support system, but it's complementary what is happening to that support system. What an aggregator is doing. So, as I said, producers and consumers, we integrated in our portfolio, which is a virtual power plant. Basically, we're controlling the power plants, the assets, let's say like this, to provide ancillary services, meaning to stop or to increase or to decrease or to increase the energy as the TSO is requesting. So there's a dispatch, and when we control them to provide these services. When the TSO is asking. So when the TSO is seeing that there is more energy produced than it's consuming, they will say, okay, you this aggregator, you will need to decrease the energy of the assets that you have in your portfolio. For doing this, the partners will receive and we will maximize their profit by doing this as the TSO request. So what are the assets that can do this? So of course, now, as I said, and we will see the example in the next slides, the batteries, so the storage, but it can be also hydropower plant storage, like pump hydro plant storage. That can be gas, that can be biogas, biomass, consumers as electric boilers, compressors, everything that is can be steer, let's say demand side response, which is known in the terminology of ancillary services. Also, nowadays, you can do it with renewables energy. So to integrate, to help them integrate, so you have wind and PV, right, as renewable energy. So for example, you are working with 20 megawatts of wind in the market. You are placing a bid on the day-ahead market, but the TSO says, sorry, we have too much consumption, and in this regard, we need to decrease the consumption. You, as a wind or solar PV power plant, if you're integrated in an aggregator, you can say, I can decrease, let's say 5 megawatts to help the system to be balanced, to the security of the system, and to arrive at that 50 hertz that it's needed. So also renewable can participate, but mainly with a downward service, AFRR minus or MFRR minus, because it's quite hard to estimate when you will produce energy when you're depending on the wind and solar. On solar, yes, But imagine that if you need 5 megawatts to balance the grid, you will say, okay, I can produce with my PV with the power plant, but there will be a cloud over that PV. So you will not provide 5 megawatts, which is crucial for the network. So that's why renewables can provide, but mostly on minus. Let's go to the infrastructure of an aggregator and what's the philosophy of these services. We see on the left upper side of this graphic that there is the frequency. So the working state is at 50 hertz. On this, we need to activate the assets which we have on the left bottom side of the diagram, sort of production, one or I don't know how many, but also source of consumption, depending on if the frequency is higher or lower than 50 hertz. So we have this system, Nano Energy's aggregator, in our case, which is a virtual power plant, basically, that is monitoring and controlling the signals of the asset. So when the TSO, as we see the figure in this picture, it's requesting ancillary services, we can provide to the TSO. What we have to arrive there, we have this ancillary service market where we do the bidding and the offer selection. It was presented before, very nice. There is this bid ladder scale, which there is a marginal price for in Romania's case for activation, and there is also a reservation price, which is pay as bid. To be available to provide the energy. In Romania, we have the case of like who can provide the services to be more than 1 megawatt. But of course, in an aggregator infrastructure, in a VPP, virtual power plant, we can have assets that it's less than 1 megawatt. For example, if it's 800 kilowatts, it can be integrated within the virtual power plant, and you can participate to the ancillary service market because we will fulfill and we will complete that 800 kilowatts with another 200 kilowatts from another asset. For example, if we have 4 megawatts of an asset and 800 megawatts, we can take from that 4 megawatts, we can take the 2 megawatts that's needed. So this is an advantage for the assets that are less than 1 megawatt. Okay, so this is the philosophy of ancillary services seen as from the eyes, let's say, of an aggregator, where we use flexibility of assets. How we are doing it exactly. So in the next slides, we will see a case study of the batteries. We own more than 36 megawatts of batteries in different countries in Europe, also in other continents in Japan, as I mentioned in the beginning. And we will see how exactly it's seen as an operator and optimizer of this asset. So in this picture, we see the activation of AFRR minus and plus of a battery. So on the x-axis, we see the time frame, and on the y-axis, we will see the megawatts. So in this case, we have a 10 megawatts battery, and we can see with the green line and the small spikes, this is the output on plus and on minus needed by the TSO. So, for example, in AFRR, you can have activation for 4 seconds, let's say, or you can have activation for 50 minutes, depending the need of the TSO. So we can see here there is like an upper limit and a lower limit where we have to fit, and with this battery we provide like, let's say, 50% of this need. With another asset, we are providing the rest of it. So let's take the first spike over here at 1650. There is an activation of downward service. So for few seconds, the TSO needed to increase the power, so we consume the energy. We see further there are some activation. Some of them they're like a range of few minutes. Some of them they're a range of few seconds. This is what is happening in a battery, and we can see like for the interval of let's say 1 hour for 1650 here until 1550 here, 1750 here. Sorry, we have lots of activation. So that means that the TSO needed the energy on plus and minus for many times. So this is on short what ancillary services means to a battery. Of course, in behind a battery, there's the numbers of cycles per day that can be done. There is the state of charge that needs to be operated. So this is what an aggregator is doing, and also optimizing how a battery works to fulfill the needs of the market. Also, you can go besides BSP, so besides the balance service provider, you can go on different markets, on day ahead and intraday markets, and this is how it looks like for a battery. Usually, you go and you sell the energy, the whole energy that you have. So you for a 10 megawatts battery, you will sell 10 megawatts, and you will charge also 10 megawatts, meaning you will consume. So this is a time frame of this battery on the trading market. Let's go and see again what are the ancillary services on this battery, which is 12 megawatts, and how's the let's say technical status of the battery is it's happening. We see the state of charge over here on the right side, upper right side of the graphic. How a battery it's working and how the state of charge is. We can see it. Imagine if you have a battery on your phone and you plug it and you charge it and you see it's, I don't know, 100% the battery charged, meaning you did a full cycle. Well, in the real case, battery is not doing every time full cycles, so you need to have this state of charge, this, let's say, percentage that you have also on the battery on the phone, to be accordingly with what is happening in that battery. So it's quite hard to do this. So for this case, what you are doing, so this is trading on BESS. We can see the difference between ancillary services and trading, but this is how you do the multi-market. So this is how you optimize a battery, so you will not have that fluctuation that we saw on ancillary services. So this is a real case study on an asset, on a storage asset that you can provide ancillary services at the request of the TSO, and you also optimize the asset. Of course, this is an example. You can do also with the CHP. For example, for the CHP, it's a little bit, let's say, similar because you're also doing the same. You're providing energy on the trading market, but also on the ancillary service market. It is a challenge for owners and for the aggregators to do this optimization, because as we have assets, as we have phone, the example that I gave, you need to know exactly the state of charge of them, and you don't want to destroy them. You don't want to decrease the lifetime of the asset that you have. It's quite important in this regard when we are providing ancillary services to have the assets in a healthy situation. So what we also providing to the customer is to see exactly the revenues and the state of charge and the daily cycles that it's that the asset is doing. On this battery, we can see here on the right side is exactly the revenues, exactly the markets that it's operating, And on the left bottom left side, we see the revenues of the battery split in different markets: day ahead, intraday continuous, imbalances, and ancillary service market. It's important to have this and to see this, to have this tool to be transparent, also with the TSO, also with the partners, and to know exactly what's the capacity of the assets that they have. What I didn't mention is, for example, for trading, we have an overall efficiency of 85%, while on ancillary services, it's overall efficiency of 62%. So it's a challenge also for aggregators, for asset owners, to fulfill this request of the TSO, to be balanced and to provide ancillary service in the same time. So thank you. This is all from my side. As you said, we manage over 400 megawatts, and in Romania we have 7 megawatts now, and we are targeting 150 next year. We know how to do for batteries. We know how to optimize them, and please, if you have any questions, here is my contact, my email address. You can find me on LinkedIn as well. And I'm open to any questions regarding the operating and how an aggregator is providing this service, balance service provider, BSP, and how we manage the flexibility of the assets. So thank you very much.
Thank you very much, Olivian. It was great to see also from the other end of Nicola's presentation how the things are happening, and I think both presentations completed each other very well in terms of the information provided. So we thank you both for taking the time to present such insightful information from your companies. Okay, now we are at the Q&A sessions. We invite the people in the meeting to ask questions. It can be for both of the speakers or for just one of them. We also have some pre-registered questions from the registration form that were submitted by the participants, but we will start with the people in the meeting. So whenever wants to ask a question, just open your mic and let us know what you're interested in. Yes, Nicola.
Maybe I have one question for Olivian. You
Yeah, go ahead.
Tried how the batteries are working, but one question, whether you are how much of the consumption you are dealing with, and the most important question is how to you determine the baseline. Do you know the issue with the baseline? So I didn't mention in my presentation because there are very small insights, but when consumer is consuming the amount of energy needed for themselves, and I don't know, supplier get it on the market, but when the TSO asks for the producer to increase the consumption or to decrease the consumption, if his participants in the balancing mechanism, how the supplier is charging the energy for consumed energy, because of course he gets on the market, I don't know, 5 megawatts and consumer is consuming 7 or 3. How that thing is dealt with?
Okay, thank you, Nicola, for the question. Well, it's a question that we also are dealing in Romania, and we are trying to solve right now. So it's a question that I will reply in let's say 2 ways. First thing is like the consumers, they need to have this contract with the supplier, and it needs to be specified in their contract that this economic let's say tool that they have, like participating as a BSP, it's happening. So they need to speak with the provider, with the supplier, and telling them that, okay, we are participating in the ancillary service market. So we are estimating that for, let's say, 5 megawatts per month, we will provide to the ancillary service market. So this needs to be transparent between the consumers and the supplier. And the second way that I will also reply, it's the technological aspect. It's, for example, if you have a consumer and let's say a brick fabric, and they need to provide this energy for their power plant, they need to be like the baseline, because the bricks, you cannot stop the thermal process that is happening, but they need to have a buffer in their system of producing the energy. For example, if there is an activation in, as an aggregator, we will speak with the consumers and we will say, okay, we will activate your asset, but we will activate for, I don't know, 15 minutes, 5 minutes. Does your process is affected or not? So they will need to have also these technical aspects fulfilled, that their technological process is not affected. And this is how we are working with the consumers. For example, if they have an asset of 12 megawatts, and we have this case in Romania, we can aggregate, let's say, 2 or 3 megawatts, so we cannot affect either the technological process, either the supply of the energy, the contract that is made with the supplier of the energy. So I don't know if I answered your question, but I think this is how we are doing in Romania.
Okay, that thing is not developed on the European level yet, and every TSO or every facilitator of the market is coping with same issues probably.
Yeah, exactly. It's not in the, let's say, regulatory framework. So this is how we are doing in Czech Republic. This is how we're doing in Germany. This is how we're doing now in Romania, in Croatia, and basically it's a, let's say, it's a behavior that it's happening because there is no this legal framework.
Okay.
Okay, thank you, Nicola. We'll move on to Sorin Ștefan in the
Hey
main.
guys, hey,
Hello.
thank you so much for this meeting. I have a question also because I'm in the front of the problem about this subject, about the capacity, 2 hour or 4 hours for system services. Now some of our owners, he want to put and to hybridize some PVs in Cluj. The OD is there, and now I have some discussion with there because the owner want to put 2 hours of capacity for PV with 30 megawatts, and after my discussion with OD, they tell me you cannot do the system services just with 2 hours. You need to put minimum 4 hours. And I tried to have some discussion with Transelectrica about this subject, because now in Romania we have just the technical norm from Transelectrica. They released from December last year about CEM and storage. And my question is 2 hours or 4 hours, because I don't know how to manage that problems. Thank you.
Okay, I think this is a very factual question here, and is most regarding the Romanian market. Well, in this topic, I can say that basically you're asking how to dimension a battery for the system. So in this regard, I just can say that for this moment there is a need of storage. So you need to have asset that can deliver the energy as fast as possible. So to answer to your question specifically, you'll need, let's say, 2 hours now. But in the future, when there will be more units of storage, battery or even pump hydro power plant, you will need less capacity to be delivered in the market. So I will say in the future you will need a 4-hour battery. In the same time, you also need to see how the renewables are developing, because if they're going hand in hand, the demand with the request, you will need the same capacity or the same storage as like in 3 years as you need right now if you have more renewables energy. So from my point of view, this is the answer that I will give to a developer that wants to install a battery. But I don't know from the other points of view, maybe the TSO from Nicola from Serbia has another reply.
Thank you.
Yes, in Serbia, we have a stipulation for the new renewable energy sources to provide the balancing capacity, meaning that it is a battery, or to build some hydropower plant, or I don't know, to get some storage, to get some capacity in the market. Basically, for the renewable sources, it would be that all time to build a battery. And we asked them, the law is not clear, but somebody will read it, that then they need to put a battery in 10% of power plant lasting 4 hours. But when you read closely the law, you can also put 20% of approved power lasting 2 hours. So I don't know, something in between, in order to fulfill that amount of energy. For market division, we are organizing the auctions for balancing capacity. We will start from 1st of January, and we will ask for offer for 4 hours. That would be, I don't know, we saw that in Germany with our consultancy company, and they gave us a solution or proposal to have the auctions on 4 hours. If there is a need for somebody to deliver for only 2 hours, I think that you need to combine it with some other resource. If the TSO is asking 4 hours and he wants 2 hours, you need to combine it, and I don't know, somehow, or reduce the energy, or reduce the power for the injection or consumption. I don't know whether it's clear, but
yeah, perfect. For me, it's clear, because here in Romania we have a law on technical norms from released from Transelectrica, and they tell you, if you want to have less rules to do a solution study, you need to put 1-to-1 battery with PV and minimum 4 hours of capacity. And now I have this problem. The owner want to put a battery by standalone, without Eolian, without PV, just standalone. And this was my question, and what I have this problem to have discussion with OD and OTS. We can put 2 hours of capacity of 30 megawatts, or it is mandatory to put 4, also for standalone batteries. But I find your answer, and thank you so much.
Thank you very much, Sorin, for your question.
Thank you.
Anyone else? Okay, if there's no one else in the meeting that would like to ask a question, we will also take one question since we also have 4 more minutes before ending our webinar. I'll take one question from the registered people in the forum. Do ancillary services by the BESS or renewable energy sources get different compensation schemes in your countries? In some way, I think you've mentioned something at some point, but if you want to answer this question would be great about the compensation schemes related with ancillary services.
Not sure what are the compensation schemes, but
like supporting schemes, as is the case for renewables, for example, with those green certificates and something.
For the batteries, we do not have any support, but there are some rumors that there will be a support for the batteries, but that came on the big disagreement of the investors because they entered into feed-in premium. I don't know, some other things in order to finance their project, and now the country or there are the rumors for the schemes for the batteries, and I don't know what will happen at the end. In the participation or in the ancillary services, we are opening the market for the renewable source. The market is open, but generally we are just writing the rules, and they will be published in any moment in next couple of weeks and before 1st of January. Every participant would be the same, and renewable sources will have an option to participate, but I don't know regarding their contract with the retailer or the participant who is getting their energy. I'm not sure whether they will participate at the end, because the state or those contracts for the support haven't dealt with the participation in the ancillary services. So if you ask me, I will definitely subsidize the energy not produced if it is not produced because of the request of the TSO. So that would be also as in any other case, if the production is not achieved, but because we deliver the request for the download regulation, it is the same. The same situation would be if the producer produced that energy, but we reduce it because of the needs of the system. But probably they will not participate if they have some specific contract for the support, or if they want to participate, they will deliver the prices which will be acceptable for them in order to reduce the loss for not receiving the compensation from the support scheme.
In Romania, I'll do it shortly because we don't have time. So there is a, let's say, supporting scheme where there is no double taxation for the energy that is stored either in batteries or other forms of storage. So if you, let's say, for example, take 10 megawatts from the grid, and you will deliver back to the grid this let's say 8.5, which we have like internal consumption of 50%. You will not pay for that 8.5 megawatts that are given back to the grid. You'll pay only that for 1.5 megawatts. Sorry, that is seen as internal consumption. So this is what is happening right now in Romania. Of course, to have storage, basically the need of storage appear when you have intermittent energy. So the idea, what is ideally, it's to have energy that doesn't have fluctuation, to be a baseline. So the storage needs to be put also with this producers that they have this fluctuation. So in this regard, there is also some incentives from the government.
Amazing. Thank you, Nicola. Thank you, Olivian. Thank you to all the people that joined this webinar today. I hope it was useful. It was a very consistent webinar. From our perspective, from NG in Romania, it was one of the most insightful and consistent webinar that we've ever organized in a topic that it's crucial nowadays, and not just in Europe, but it was very interesting to see two different perspectives and here, not just from different countries, but from different actors in those countries. And we will follow up this webinar by posting it on YouTube. So if you want to deep dive on this information, you can check that webinar on YouTube, or write further to our speakers for more details, and if you want to get in contact with them. Thank you all, and wish you a very pleasant rest of the day. Goodbye.
Thank you all. Thank you, participants. Thanks for the questions. Bye.
Thank
Thanks
you.
very much.
Thank you, Elena. Thank you, Jana.
Thank you. Bye bye. Have a nice day.
Have a nice day.
Very
Bye-bye.
much.
Goodbye.
Sziasztok!